Depositional coastlines are dominated by beaches such as this one that you see. The layer of sediment along a coast can insulate that coast from rapid erosion. The wave energy is expanded in churning the overlying sediment particles, which cannot erode the underlying bedrock. So, with time, erosional shorelines can evolve into depositional ones. The main factor in determining if a coast is dominated by erosion or deposition is its history of tectonic activity. The coasts of the United States along the Atlantic and the Gulf of Mexico have not seen significant tectonic activity in the few in a few hundred millions of years, and except in the Northeast have not experienced post-glacial uplift. These areas have relatively little topographic relief, and there is now minimum erosion of the coastal bedrock. On coasts that are dominated by depositional processes, most of the sediment is being deposited, and it typically comes from large rivers. An obvious example is where the Mississippi River flows into the Gulf of Mexico. Another is the Fraser River at Vancouver. There are no large rivers bringing sandy sediments to the west coast of Vancouver Island, but there are still long and wide sandy beaches there. In this area, most of the sand comes from the glacial-fluvial sand deposits situated along the shore behind the beach, and some comes from the erosion of bedrocks on headlands. So if we look at the United States, we can say in general that the Gulf Coast and the East Coast are depositional coastlines, and the Pacific Coast or the West Coast is an erosional coastline. This is a composite diagram of the large-scale features of an imaginary depositional coast. Not all of these features would be found in such close proximity on a real coast. These features are primarily deposits of sand moved by a longshore drift. The longshore drift creates long, narrow shoals of sands called spits. The longshore drift can also create or destroy barrier islands, such as these ones. Barrier islands are long, offshore deposits of sand situated parallel to the coastline and are separated from the coast by a lagoon or a bay. Here you see Sepetiba Bay in Rio de Janeiro, Brazil, separating the barrier island called Marambaia Barrier Island from the mainland in the state of Rio de Janeiro. These two maps show barrier islands on the coast of North Carolina and Texas. The aerial photo shows a heavily developed barrier island off the coast of New Jersey. According to a recent global satellite study, 2,149 barrier islands have been identified worldwide in every climate, and nearly 300 ring the Atlantic and Gulf coasts of the United States. There are no barrier islands on the Pacific coast, so this image shows the presence of barrier islands in red on the Gulf Coast and the East Coast of the United States. Again, there are no barrier islands on the Pacific coast, on our coast. Longshore drifts deposit, remove, and redeposit sand, so these barrier islands are constantly changing. The small picturesque island of the southern end of Long Beach Island, Tucker's Island, was once a popular seaside resort. It had a lighthouse, as you can see in this photograph, a life-saving station, hotels, and summer cottages. The hotel closed in 1910 and later collapsed and was washed away. The lighthouse that you see here fell in 1927 and it's now submerged under the sea. You can read more on the link that I'll post on the page for you about the mystery of Tucker Islands in New Jersey. It's recalled as Tucker Islands, New Jersey's Atlantis, because the island disappeared. But it was built in a barrier island, which is constantly changing due to the movement of sand. Sand spits form where longshore current slows down and clears a headland as approaches a quiet bay. The slow current is unable to carry sediment, and so the sand spit develops. This is Farrell Spit in New Zealand, and it's at 32 kilometers in the northwest area of South Island. It is believed to be formed by the strong prevailing winds and currents that eroded the southern Alps in the South Island, depositing the sand into the Golden Bay. Recurved sand spits form when wave refraction occurs at the end of the spit, carrying sediment around the end and forming a hook. A bay mouth bar is when a sand spit closes off a bay, attaching a headland attaching a headland adjacent to the bay, and then the inlet is can be cut through, providing a passage from the bay to the ocean. Another feature of depositional coasts, the tombolo and the former islands. Rising ocean separated islands which were high points on the mainland, and sedimentary processes surrounding them with beaches. If the island is close to shore, a bridge of sediment called the tombolo may accumulate and connect the island to the shore, to the mainland. So here you have a diagram showing a former island connected to the mainland, and here an example of a tombolo at Gold Rock Beach in California. Here the tombolo connecting the island to the mainland. Another example, this is Greyhound Rock in Santa Cruz, connected to the mainland by a stretch of sand called the tombolo. Deltas is another feature of depositional coasts. They are formed when sediments wash off the land, building on the coastline. The coastline needs to have a broad continental shelf, a low tidal range, and mild waves. Deltas are common in low energy shores, often closed seas, and tectonically stable. Largest deltas in the world, the delta of the Mississippi River, which you can see here photographed by a satellite, and the delta in the Mediterranean Sea of the Nile River. These are the largest deltas in the world.